Hello, everyone. Today is December 20th, 2022, and it has taken a little time to release the data, but I finally got some interesting data to share, and it has to do with the earthquake offshore California. It's a 6.4 magnitude earthquake just outside of the Eureka city. It's a very interesting place from the point of view of seismology, and let me show you why. Let's travel a little with Google Earth, okay? And you can see here a lot of scars in the middle of the ocean. We already talked maybe about them. There are transfer faults that had to do with plate movement, plate tectonics. But the interesting thing about this specific epicenter is that it occurred in what is called the Mendocino triple point. This big scar that you see over here is a transform fault called Mendocino. It's a right lateral transform fault. And over here is a very interesting piece of plate. It's a microplate, a mini plate called the Juan de Fuca plate. You can see the boundary on these other scars over here. Actually, there's some transform movement, but also there may be some spreading along this part of that ridge. Subduction occurs in this part of the North America plate. And the interesting thing here is that another feature comes out here is a well-known San Andreas fault that runs down south. It's a right lateral, so it's a way of transforming the Mendocino fault into a change of direction, kind of, when it hits the continent and it converts into a right lateral fault called the San Andreas. So we'll see this with a different figure. So let me show you that. Here we see the same area, but it's still picture with some information. And we see the main features. We have the Mendocino fault, which is a right lateral transform fault hitting the North American plate in that position. But now we have a small plate called the Juan de Fuca plate. Actually, seems like it's called Gorda plate also in this area. I learn something every day. And that plate pushes the North American and it seems to have a subduction zone. So there is subduction in this particular place. But that triple point called the Mendocino triple junction, all three features converge to a point, and there is another interesting element comes out into play, which is the San Andreas fault, which runs south southeast and is also a right lateral type of fault. So this earthquake, this particular earthquake, and there has been some, by the way, the same day in 2021, at about the same location, we have a 6.2 earthquake. So very strange coincidence on the same day. Okay, so this is a very promising position for an earthquake to happen. Okay, there's a lot of pressure going into from all these uh, different features, the faults moving, the subduction that's taking place. And let's see at the later on, let's see the source mechanism to see which one of these faults may have a predominant movement in the generation of this particular earthquake. So let's come back to our source of information. And here again, we are with the epicenter located just close to Eureka, and that triple point happened somewhere in here. It's a 6.4 earthquake. It's a 17.9, 18-kilometer depth. That's quite shallow. So they may have been some surface wave generated. Again, I don't know any reports from damage. I will look at it after I record this little piece of this video. But I want you to just look at some records since it's part of our way of promoting these uh, videos. Okay, here we have a record somewhere in Oregon at about, let's say, we have a distance of 4 degrees, so that's about 400 kilometers, if I'm correct. And let's look at the again the records at that position. The total recording time for the event was about, let's say, 6 minutes. Remember from one of the videos, if not look at it, when we talk about records and how to read them or look at them, we have here the arrivals of P in red, PP is yellow, and in blue we have the S, and in light blue the SS arrivals. Remember, those are good to determine the depth of the event. Okay, we see some surface wave generation is kind of important energy in that part of the record. Let's look at some other records long farther away. This is Tucson, Arizona, which should be about 100 kilometers or so, I hope. And again, a much longer time. We have the P arrival, the S arrival, remember, is farther away, so it takes longer time. Also, the surface wave are longer wave trains, takes longer time, they're dispersive. We first may have some Rayleigh motion and then some pseudo Rayleigh and Love energy coming through the horizontal seismographs. Okay, so just want you to give you all this information so you can have a different way of looking at it. Well, by now there is not a source mechanism provided by the page, so we may have to look at in another source of information. They do not report it yet. Maybe too early. It takes time to do that technical work. So this is about what we have on that particular earthquake. I think it's a very important from the point of view of the planet, uh, tectonic plates, the position of that particular epicenter related to some of the plates and the major faults in the area. Let me see what else we can get from YouTube and some play and see what we can add to this particular video. Looking into the USCS information page, we have the moment tensor result for this particular earthquake, the 6.4 California earthquake. Very interesting because it kind of corresponds what we expect in the area. If we look at some other information, we'll see that this moment tensor corresponds to a dextral fall movement type, which is what we expect. A dextral movement is a right lateral movement, and we have in that particular point the Mendocino, which is a right lateral, and we have the San Andreas fault coming in, which is right lateral. If we look at it closer, it actually looks like the fault may have been the almost east-west trending compressional lateral, right lateral movement according to this specific moment tensor. So this is my preliminary interpretation. We'll see what comes out of other studies. But I will put this as a right lateral with the fault plane going along this line. After finishing the other part of the video, I found the aftershock records, and look how interesting. These aftershocks are aligned along the direction of the predicted fall mechanism and fall direction and movement on the total moment tensor. Very interesting. Remember this direction. Look at the video earlier and you will see that. Very interesting. Well, for now, saludos por el mundo y gracias.